Okay, let's look at 26 here. Okay, let's look at the absolute value. Remember, the first number is your A, the second number is your B on these. What's the absolute value of 7? What's the absolute value of -2? So is your A greater or smaller? Greater. So what type? First of all, what family does this belong to? Lambison, because you got to put a minus here. Okay, now we've got to determine which one. A is greater, so will it have an inner loop or will it have a dimple? Dimple, will it be at the pole? No. Okay, does everybody understand that? Okay, so check your work here. I did the table. Number 7's right here. Check your answers. That's the table. Yes, it went off the graph. I'm going to show you what happens if it goes off the graph, how to handle that. Great job. That's how you handle that. Are there any questions how I got these values here? Yes. Okay. You plug in your major points. 0. Sine of 0 is 0. That all cancels out, leaves you 7. Sine of pi over 2 is 1. 1 times -2 is -2, and go from there. Okay? Now, that is the graph for number 26. Do you see how I came out and just like extended the line? And this was, I think, how many lines? That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I drew a little line and put 3 more curves on it and just put a point right there. Do you see how I handled that? Is everybody good with that picture? Max, you good? Okay, how do I know where my dimple is going? Okay, first of all, these are the relatively same spot on the axis, aren't they? Your dimple's not going to be there. This is the furthest away from the pole, isn't it? It's not going to be there, so this has to be the dimple's going to be there. The dimple's not going to be at the point furthest from the pole, okay? So everybody good on that one? Alright. Let's look at 27. Check your... Right now you can go on and check all your tables, and then we can look at the drawings. There's your 27, 28, 29. Take a moment. Are there any questions how I came up with those values? So let's look at the equations in general for just a second. 27. The A is greater than the B. So, first of all, overall, what type of equation is this? A Lambison, because it has a minus in there. The A is greater. Is it inner loop or dimple? Dimple. Is the dimple at the pole? No. Number 28. What type of polar equation is this? Lambison, because you got a plus. Is it inner loop or dimple? Why? Because the A is what? Less than. Very good. Number 29. What type is this? Lambison. Is it an inner loop or dimple? Because the A is what? Does everybody understand that? Okay. So let's look at the graphs for those. Okay, on number 27, I had to extend the graph a little bit. This is furthest away from the pole, so that's not going to be my dimple. These are in the relatively same, they're on the same line, so that has to be my dimple. Notice that it is cosine. It is cosine, so it's still around that horizontal axis. Number 28, that point is coming inside, so I know that's where my inner loop is going to be. Make an inner loop. I had to extend the graph a little bit. And then 29, just check your work. This is all we're doing this week is practicing graphing and telling me what type they are. Your test is on Friday. Yes.
But didn't you say we're going to teach us how to graph it like on a calculator?
Yeah, that's going to come tomorrow.
So what's today, roses?
Roses. Rose petals. They more look like tulips, but they call them roses. Mm-hmm. All right, are there any questions on your homework? Didn't we have to do 37 as well? Okay, what type, how do you know, what type is this? It's got R squared. Lamacent. Okay, so I'm looking off bow tie. I know that because the R squared. Okay, you take the square root of the number in front of sign. That is 1. What's the square root of 1? 1. So since it's sign, you're going to be on the vertical. You're going to go 1 unit up and 1 unit down and put a dot at the center. It's very important to know that there's a dot at the pole on these. You've got to have those graphed, okay? Dot here, and on the circles, there's a dot at the pole on the circles, okay?
Can you do number 38?
Number 38? Okay, take the square root of 2. Somebody take the square root of 2 on your calculator. 1 point what? 1.41, okay? That means I'm going to go up to 1.4 from my, okay, sign is going to be on the vertical. You just estimate. And there you go. That's all you have to do. I didn't do a very good bow tie there, but yeah, that's all you have to do. Take the square root of that too. That was your homework for tonight, so you just did one. Okay. Now let's talk about roses. Are y'all good? Can we move on? Let's get 2 examples of that. I want you to turn to this page for roses, right here. Now roses are a little bit more complicated process. You remember those tree equations, the ones you didn't like, that you had to plug that n be equal to 0, n equal 1, n equal 2, n equal 3. You remember those? You have to do that on these. That's why we learned it back in the day. You remember where you had to find that 2 theta equals blank plus 2 pi r and divide. You have to do that on these. So it reviews that. All right, so roses. The characteristic of roses are there's no plus or minus. You see there's no plus or minus in the equation. The only ones that have plus or minus are lamacents, okay? And lamacents are squared. So the difference is how one tells the difference between a circle and a rose. In a circle, what number is in front of theta? 1. They have different numbers in front of theta. Do you see that? That's the difference between a rose and a circle. Is everybody good? Do you see that? Mm-hmm. I need a hand signal. Okay. Okay. Now, the number in front of your theta helps you determine the number of petals that's going to be on your flower, okay? If it's even, like this one and this one, you take that number and multiply by 2. That's how many petals is going to be on your flower. So 2 times 2 is what?
4.
4 times 2 is 8. That's how you determine the petals. If it's odd like this one and this one, then that's just the number of petals. You will have 3 and 3. Even, you multiply by 2. Odd, it is whatever it is there. Does that make sense? Is everybody good with that? Okay. So let's write that up there. If n is even, if n, and this is n, if n is even, then 2 times n. If n is odd, then n. I'm going to put this. Right there. All right. So we can go and put that this one has how many petals? 4 petals. You need to put that there. Now, the number out in front of sine and cosine is always known as the A value. That number out in front of sine and cosine is the A value. The significance of that A value there tells you that's how far your petals go out for what ring. So in this first one, that the petals are going out to the what ring? The 5th ring. Does everybody understand that? The 5th ring. Okay, so we need to know the values that make this equal to 5. So what I do is I set the ring 5 equals 5 sine of 2 theta. You want to know what makes this go out to the 5th ring. That's why I plug it into equal 5. And the negative value, okay? So you see, Ms. Chester, so on this one right here, because of that number right there, would I set the equal to 5 and negative 5? Yes. Right here, that is 2. I would set that equal to 2 and negative 2. Does everybody see what I'm doing? I set this equal to whatever the A value is, because you want to know what causes that to go out to the 5th ring. And so for like right here, I would set this equal to 3 and negative 3. Is everybody good so far? Write that down on your paper however you need to remember it, okay? Now, I need to get this sign by itself, so I'm going to divide both sides by what? 5. Guys, because we set that equal to that number every time, what's going to happen to all these equations? What's going to, after you divide, it's going to equal to what? 1 and negative 1. So you can really skip that step from now on, because now you see y is equal to 1, negative 1, and just put that part equal to 1 and equal to negative 1. Does that make sense? This part right here. And you can skip that and just set that part equal to 1 and negative 1 each time, because now you see y, because you're setting it equal to that A value. Does that make sense? Is everybody so far? Okay, now these are the equations we solved in that chapter. Remember, you ignore the 2 at the beginning. What sign value gives you 1? What major point gives you 1? Pi over 2 doesn't. So remember, you're going to say 2 theta equals that pi over 2 value plus what? Do I put pi in or 2 pi in? 2 pi in. Because what sign value gives you 1? Pi over 2. Now how do I get rid of theta? Divide it by what? Divide everything by 2. And when I divide everything by when I divide this by 2, does it affect the numerator or the denominator? So that's be pi over 4 plus pi n. Is this coming back to you? Okay. Now, is this coming back to you? Okay. I let n be 0. We don't want it to go. You remember how we had to solve once it went over 2? That's what you're doing here, okay? If I plug 0 in, what is it? Pi over what? 4. I plug 1 in. 1 times pi is 1 pi. 1 pi plus 1/4 pi, you would type it in your calculator. What does 1 and 1/4 pi give you? 5 pi over 4. Very good. If I plug 2 pi in there, will it go over 2 pi? Mm-hmm. Now I'm going to go over to my other equation. Negative 1 equals sine of 2 theta. That would give me 3 pi. I'm going to come over here. I'm going to come down here and do that one. Negative 1 equals sine 2 theta. Okay, so 2 theta would equal, what this give me, what value gives me a sine of negative 1? That's 3 pi over 2 plus 2 pi n. Get 3 pi over 4 plus pi n. So here's 2 of my petals right here. That's 2 of my petals right there. I'm about to find the other 2. Because how many petals we're going to have? 4. So I'm going to plug 0 in, and I get 3 pi over 4. I plug 1 in, I get 7 pi over 4. There's my other 2 petals. These take a little bit of math work. Okay, on the roses, you always have one at the center, at the pole. And what you do, guys, is what ring did these go out? What did we tell you? This ring goes out to 5. So you're going to graph all these at the 5th ring, okay? So pi over 4, which is right here, 1, 2, 3, 4, 5. That's going to be a petal. Okay, 3 pi over 4 is over here. Five pi over 4 is over here. And 7 pi over 4 is right here. Now watch how I do this. That's why they call them roses, because they say they look like flowers. And that's your graph of that particular function. Looks like a daisy, doesn't it? Sitting back in middle school, did you ever think you're going to grasp something look like that? Okay, let's do another one. I'm going to build your confidence. Let's do another one. Number 10. How many petals am I going to have? 3. Okay, now, it's always at the origin. Now, I'm going to tell you this. Do I have to go through this process here, dividing everything by that number? No, we can just set it equal to 1 and negative 1, but I'm going to give you a little shortcut here. If it is odd, if you have odd number petals, you don't have to set it equal to the negative value because they repeat in odd, okay? But in even petals, you have to set it equal to 1 and negative 1 because that gives you different values. But in odd, you only have to set it equal to the 1, okay? So let's look here. So I'm going to set, now when you set this equal to 1, you don't need the 5 now because we took the shortcut. So you just say sine of 3 theta equals 1. Because it's odd, you don't have to do the 2 equations. You can only do the first one. Okay? Now, where does my sine value give me 1 at, guys? Pi over 2, okay? So I'm going to say 3 theta equals pi over 2 plus 2 pi n. I'm going to divide by 3. When I divide by 3 here, it affects the numerator or denominator. So that gives me pi over 6 plus 2/3 pi n. Because, guys, we are only doing one equation and we have 3 petals, how many answers do you think you need here? 3, because you got 3 petals. Does that make sense? If I plug 0 in, what's my first one going to be? Pi over 6. I plug 1 in. Now, I can do this in my head, but you might need to type this in the calculator. If I plug 1 in, that's going to give me 2/3 right there, isn't it? 2/3 plus 1/6. That's going to give you 5 pi over 6, won't it? 5 pi over 6. Now I'm going to plug 2 in. 2 times 2 is 4 pi over 3. 4 pi over 3, that gives me 9 pi over 6, which reduces to 3 pi over 2. So those are my 3 petals. Pi over 6, 5 pi over 6, and 3 pi over 2. Good morning, Ms. Clemens. We are graphing roses today. All right. Now, let's graph those. We got pi over 6. Now, how do I know what ring to go out to? What's my A value? 5. Do you see that? So I'm going to go to pi over 6 and go out 1, 2, 3, 4, 5. 5 pi over 6. 1, 2, 3, 4, 5. And then 3 pi over 2. 1, 2, 3, 4, 5. And this one only has 3 petals. And that is my flower. That's my graph for that particular problem. I'm going to change homework in just a minute. We're not going to do all that. I want you to do number 11 and 12 for homework, okay? Is everybody good with that? 11 and 12. We're going to continue this tomorrow. We're going to review this. You're going to do 2 checkpoints tomorrow since we don't have time. So you do number 11 and 12 right now, okay? Do number 11 and 12 right now. We might can go over 11 before we leave. Just know you're going to have 2 checkpoints tomorrow. I'm going to give you about 3 minutes to do number 11. We're going to go over 11. Let's go. First of all, how many petals is number 11 going to have? And they're going to be out to what ring number? 2. So since this is odd, you need to have 2 equations or 1 equation? Just set it equal to 1. Yes.
So, like right there, when we have what's equal to
1.
put 0.
0. That's a great question. She said it would put 0 to 5. 0. So right now, you should have 3 petals. Cosine of 3 theta equals 1. That's what you should have so far. Cosine of 3 theta equals 1. The value of cosine that gives you 1 is 0. 0 plus 2 pi n. Now go from there. Divide by. Once you do that, you get this. You got to divide everything by 3. That gives me 0 plus 2 pi over 3n. I plug in 0, I get 0.
What if it's exactly
2 pi over 3, you don't get that. Divide by, times that by 2, that gives you 4 pi over 3. That should be your 3. Because you let 0 be n, that gives you 0. 0 plus 0. Plug 1 in. 1 times 2 pi over 3 gives you 2 pi over 3. Plug 2 in. 2 times 2 pi is 4 pi over 3. Does that make sense, son?
Well, like if you plug 3 in, wouldn't the 3 cancel out?
Yeah. No, we don't want it to be that.
Okay.
But that would just be back to where it started with.
Oh,
Because you had
yeah.
0. You see what I'm saying? We go out to the ring, what? 2. And you get something that looks like that. Is it making more sense? You better have a number 12. You only got 1 homework problem. We're going to do the rest in class tomorrow. Now, if you don't want to be here tomorrow, that assignment that's on board, you can make sure you do it homework at 30 to 32. Yes, I'll be here all day today. Oh, by the way, you know that those Saturday sessions that we've been doing for ACT prep? Today I'm going to say, and I'm going to video record myself going through all that and create a Google Classroom, so if you want to be at home and go through that ACT prep, you can, okay? I'll be here Saturday. Yes. I will be here 7th period if you want to come make up a vector quiz. I'll be here 7th period, okay? You got number 12. What you need to do tonight is do number 12 and look through your notes and see if there's anything you don't understand at the moment. Does that work on? Okay, let me stop this.